What is a vector? Let us try to understand what a vector is with the help of following examples. Let us say you walk 3 miles at first, 3 miles, then you walk 4 miles. Now what is the total distance you walk? What is the total distance? Total distance. What is the total distance? It is just 4 mile plus 3 mile. 4 mile plus 3 mile equal to 7 mile. It is very simple. So the total distance you walk is 7 mile. Let us take another example. Let us say this is your bag. This is your bag. Let us say this is your bag. The mass of this bag is half kg, and you have put some tomatoes and potatoes inside it. Tomatoes and potatoes inside it. Okay, maybe 5 kg potato and 3 kg tomato. So what is the total weight of this bag including tomatoes and potatoes? Yes, it is half kg plus 5 kg plus 3 kg. So it is 8.5 kg. So far it is very simple. Let us take another simple example. Let us say at first you walk 3 miles towards north, 3 miles towards north, then you walk 4 miles towards east, 4 miles. This is north, this is south, this is east, and this is west. So 3 miles north, 4 miles east. So what is the total displacement? What is the total displacement? What is your total displacement? Displacement. Okay, what is your total displacement? First of all, what is displacement? What is displacement? Displacement is a line segment. Displacement is a line segment with a direction where the direction is from its initial position to the final position. This is displacement. So displacement is line segment with a direction, with plus direction is from initial to final position. Final. So this is a displacement. So in this case 3 mile towards north is a displacement, isn't it? Because it has a line segment which is 3 mile, and it also has a direction towards north which is from initial position towards the final position. So this is a displacement. Similarly, this is also a displacement where the line segment is 4 mile and its direction is towards east, which is from its initial position to the final position. So this is one displacement and this is another displacement. Now I am asking you, what is the total displacement or the resultant displacement? So the resultant displacement should be from the initial position to the final position. It should be the line segment from the initial position to the final position because of its definition, and its direction should be from initial position towards final position, which is somewhere along the northeast direction, isn't it? Along the northeast direction. So I am asking you, what is the resultant or total displacement? So it is not just 3 mile plus 4 mile equal to 7 mile. It is not like that. You can see from its picture, from this picture, this is just 5 mile. So it is just not adding up like earlier examples. Here you just add them up, isn't it? But in this case you cannot add them up so easily. There is some different kind of addition for getting total displacement. So by this example, what I want you to understand is, in the initial cases I was not interested about their direction. I was just talking about their magnitude, magnitude, means how much, how far. These things are called magnitude. So I was interested about how much or how far, and I was not interested about direction, which means towards north, towards east, from initial position to the final position. I was not interested about those things. These quantities are called scalar quantities, where I am not interested about their direction, and these quantities are called vector quantities, where I am interested about their direction. So these quantities are different. They are scalars and these are vectors. So these quantities are different from two aspects. They are different from two aspects. You can see, first aspect is scalar quantities. In case of scalar quantities, we are not interested about their direction, and in case of vector quantities we are interested about their directions. And second thing is, scalar quantities just add up. If you want to get the total, we just add them up simply. But in case of vector quantities, they just don't simply add up. They have different addition process. So from these two aspects they are different. Let us see one more example. If I say a car is moving with a speed of 30 mile per hour, then it is a scalar quantity, because I am not interested about direction, so it is a scalar quantity. Speed is 30 mile per hour. But if I say a car is moving with a velocity 30 mile per hour to west maybe, so here I am not only mentioning the magnitude, but also I am mentioning a direction, so it is a vector quantity. Though they look same, because both speed and velocity both actually give the rate of change of position, but in case of speed we are not interested about direction, but in case of velocity we are interested about direction. So you can think velocity is like speed with direction. So when we will deal with more vectors, you will be more clear about them. And so keep watching next videos and have fun of physics.